Okay, let's think about this. Every single day, you and I, we rely on dozens of apps, right? For work, for talking to friends, for basically everything. But have you ever stopped to wonder what's going on behind the scenes to make sure they don't just fail? Today, we're going to pull back the curtain on software testing. It's this hidden, super disciplined process that, honestly, keeps our whole digital world from falling apart.
Oh, you know the feeling. We've all been there. You're right in the middle of something important, and then bam, the app freezes, or it glitches out, or just poof, closes on its own. It is so frustrating, right? And look, even the biggest, fanciest tech companies have bugs. Well, that exact, universal feeling of frustration, that's the problem software testing is built to solve, long before that app ever makes it onto your phone.
So, what exactly is software testing then? I'll tell you what it's not. It's not just some person randomly clicking around hoping to break things. No way. It's a real professional discipline. It's the formal process of checking out an application to make sure it actually does what it's supposed to do. You can think of it like a quality inspection for code, hunting for any little defects or gaps between what was promised and what was actually built. All right, let's talk about the mission here. Why do we even test? Now, you might think the answer is simple, to find bugs. And yeah, that's part of it, for sure. But the real goal? It's way bigger than that. It's all about building confidence and baking quality in from the very, very start. So the main goals of testing are actually super proactive. It's not about playing whack-a-mole with bugs after the fact. It's about validating that the software actually meets your needs, the user's needs. It's about identifying defects, of course, but also ensuring the whole thing is reliable. And a big one, reducing the risk of that crash we all hate. Ultimately, it all boils down to one thing: making sure you, the customer, are happy and confident using the product. Okay, so to get all that done, you can't just wing it. You need a plan. Actually, you need two plans. Think about building a house. You've got the main blueprint for the structure, right? But you also need a separate detailed plan for all the electrical stuff. Software is kind of the same. It relies on two big interconnected blueprints, one for building it and one for testing it. So first up is the master blueprint, the Software Development Lifecycle, or STLC for short. This thing lays out the entire journey of creating software. It starts with analyzing requirements, then you design it, then you code it, you test it, you deploy it, and you maintain it. But look closely at that list. See where testing is? It's not tacked on at the end. It's a core, essential phase of the whole build. That is absolutely crucial. And running right alongside that is the tester's very own blueprint, the Software Testing Lifecycle, the STLC. This is the step-by-step game plan that testers follow. Just like the developers, they start by analyzing the requirements, then they plan their whole testing strategy, they design super specific test cases, they actually run the tests, report back on any bugs they find, and then finally, they wrap up the whole process. It's this methodical, structured journey to guarantee quality. Now, in the testing world, you're going to hear two terms thrown around a lot: QA and QC. They sound almost the same, but they're really different philosophies. Quality assurance, that's QA, is all about the process. It's proactive. It's about preventing bugs from ever happening in the first place by making the whole development process better. Then you have quality control, QC. That's all about the product itself. It's more reactive. It's about finding the bugs that are already there. And here's the thing. To build truly great software, you absolutely need both. And this leads us to a really fundamental idea in testing, and it boils down to one simple but crucial question that testers are always asking themselves: are we building the product right? This is all about the process. Are we following the plan? Is the code up to snuff? This whole idea is called verification.
So, verification is one half of a super important duo. Verification is asking, are we building the product right? It's like, are we following the recipe correctly? But then there's validation, and that's asking, did we build the right product? Let's use a coffee shop analogy, because who doesn't love coffee? Verification is the barista making sure they use the right beans, the right amount of espresso, steam the milk to the perfect temperature. They're following the process. Validation? That's when you take the first sip and say, yep, this is the delicious latte I ordered. See the difference? Process versus the final product.
And really, this is the million-dollar question, isn't it? Are we building the right product? Because look, it doesn't matter how perfectly you followed the blueprint if you ended up building the wrong house on the wrong lot. Validation is what confirms that the software actually solves the user's real problem. It's the ultimate reality check for the entire project.
Okay, so how do testers keep all this straight? I mean, they're not just winging it, right?
Of course not. They have a whole toolkit of documents they use to organize everything, taking them from the really big, high-level ideas all the way down to the nitty-gritty details.
Everything kicks off with something called a test scenario. The best way to think of this is like a chapter title in a book. It's a big, high-level statement that just says what we're going to test. So a classic example is verify the login functionality. Super simple, right? It's broad, and it just sets the main goal.
Okay, so if the scenario is the chapter title, then the test case is the detailed step-by-step recipe inside that chapter. This is where we define exactly how to test that scenario. It lists the specific things to type in, the buttons to click, and, this part is key, the exact result you expect to see. A good test case is so clear that literally anyone on the team could pick it up and run the test without any confusion.
Let's look at a real example. See this? Every test case gets a unique ID, like TC001 here. The description is simple. Verify valid login functionality. There's a precondition. You gotta have a registered user to start with. Then the steps. Step 1, enter a valid username and password. Step 2, click Login. And the expected result? The user should land on the home page. If that happens, you mark the status as pass. It's totally clear, anyone can repeat it, and you know exactly what success looks like.
So you've got all these requirements from the customer, and you've written tons of these detailed test cases. How in the world do you make sure nothing gets missed? Like, how do you guarantee you've tested every single thing the customer asked for? Well, that's where this amazing tool comes in, the Requirement Traceability Matrix, or RTM. It's basically a master spreadsheet that connects every single requirement to one or more test cases.
And why does this RTM thing matter so much? It's simple. It's your proof. It ensures 100% test coverage. It's the document that lets you say with complete confidence, yes, we have a test for every single thing you asked for. Nothing gets missed. It is the ultimate safety net. Now, it's really important to understand that testing isn't just one big thing you do at the end. It's actually a series of layers, kind of like an onion or a castle's defenses. Each layer builds on the one before it, creating this defense-in-depth strategy to catch bugs at every possible stage. So we start at the smallest level. First is unit testing. That's where developers test a single tiny piece of code, like one little function. Think of it as checking a single Lego brick. Then you have integration testing, where you snap a few of those bricks together and make sure they fit. After that comes system testing, where you test the entire, fully assembled Lego castle. And the final layer? That's acceptance testing. That's when you hand the castle over to the client and they confirm, yep, this is the castle we wanted. You see how the confidence just builds and builds with each layer?
All right, we're almost there. Once we're pretty sure the whole system works, there's one last big quality check. And it really comes down to two different questions. First, does it work? And second, does it work well?
And those two questions break down into two main types of testing. You've got functional testing, which is all about the features. Does the login button work? Can you add an item to your cart? It answers, does the feature work? But then you have non-functional testing. This is about how well the system performs. Can 1,000 people log in all at once? Is it secure from hackers? Is it easy to use? You know what a shopping website crashes on Black Friday? That's a classic failure of non-functional testing. So you see, you need both. It's not enough for it to work, it has to work well.
Okay, so let's quickly wrap this up with the big takeaways. If you remember anything from this, remember these 4 things. 1. Testing isn't just random clicking. It's a planned, structured process with its own blueprint, the STLC. 2. Verification is about building the product right, and validation is about building the right product. Huge difference. 3. Testers work from big-picture test scenarios down to super detailed recipes called test cases. And finally, 4. Testing is done in layers, from the tiniest bit of code all the way up to the full system.
So I want to leave you with this one final thought. The next time you open an app and it just works, it's fast, it's smooth, it does exactly what you need it to do without a single glitch. Just take a second, because now you know that's not magic and it's not an accident. It's the result of all this deliberate, structured, and mostly invisible work we just talked about. So now that you know, what hidden work will you see?